Okay, I'm going to run through a couple of examples of adding mixed numbers. There's a few skills that you need to know here. Firstly, whenever you're working with mixed numbers, you need to be confident on getting from mixed numbers to improper fractions. We're going to do the same here. Also, you need to be confident with adding fractions. Remember, adding fractions isn't the easiest of operations to do. You have to make the denominators the same, then add the numerators to carry out adding fractions. After that, you need to be confident with simplifying, and you need to be confident with going back from an improper fraction to a mixed number. Okay. In general, if your question is given to you as a mixed number and you get an answer that's an improper fraction, you want to convert it back to give it in the form that they gave it to you in, unless the question specifically says otherwise. So this is just like dividing, multiplying fractions. I'll write out the steps. The first thing you want to do is convert to improper fractions. Okay, improper fractions are a lot easier to work with than mixed numbers. Whenever you see a mixed number, your first instinct should be, I want to be an improper fraction instead of a mixed number. As with before, you can work this out with mixed numbers, but there's more parts to it and there's more things to remember. So you might as well, as instinct, just always go to improper fractions, and then you work with them as if they're just normal fractions. Okay, so you've converted it to an improper fraction. Then all you're going to do is carry out the addition. Okay, so when you're adding two fractions, you need to remember all your steps. Then you're going to, now these two can be done interchangeably, and I'll show you in one of my examples. So you want to simplify, and then you want to convert back to a mixed number. Okay, so I'm going to do a couple of examples. I'll show you each of the steps. Let's get started. So we're going to start off with 2 1/3. 2 1/3 plus 2 7/9. Okay. So step number 1 was to convert them into improper fractions. So let's do that. We're going to do 2 times 3 is 6, plus this extra 1 is 7. So this is 7/3. That's that one converted. Now let's convert this one. You've got to do 2 times 9 is 18. 18 add 7 is 25. So that's 25/9. That's that one converted. Now we need to carry out our addition. So if you remember, when you're adding two fractions, if you're not sure what to do in this, I've done a video on adding fractions. You need to make the denominators the same. You need to make these bottom numbers the same. So we're looking for a common, lowest common multiple. Well, 9 and 3 are both in the 3 times table. Okay, 3 times 3 gives us 9. So I can times this whole fraction here by 3 on the top and 3 on the bottom, and then our denominators will be the same. So let's do that. So we're going to take the bottom and times it by 3. 3 times 3 gives us the 9. That's what we were after. Then we're going to have to times the top by 3 as well. So 3 times 7 gives us 21. Okay, this already has a denominator of 9, which is why we chose 9. So we don't have to worry about that one. Okay, next up we have to add our two numerators. So we've got 21 add 25 to give us 46/9. Can we simplify this? Well, 9 only has factors of 9, 3, and itself. 9, 3, and 1. 1 is pointless because we'd cancel out 1s. We could do that all day and nothing will change. If 3 goes into 46, then we will be able to cancel it down. Does 3 go into 46? Our divisibility check. If we add 4 and 6, we get 10. 10 is not divisible by 3, so this cannot be simplified any further. So we've done the first one. We've changed it to an improper fraction. We've then carried out the addition. We've shown that we cannot simplify, so that's fine. Now we need to convert to a mixed number. So how many 9s go into 45? Well, 9 times 5, sorry, going to 46. 9 times 5 is 45. So that is 5 lots of 9 gives you 45. That gives you 1 left over. So 5 and 1/9 is the same as 46 over 9. And that is your final answer given as a mixed number. Next question. We're going to have 1 and 7/10 plus, so 1 and 7/10 plus 2 and 5/6. First thing we're going to do is convert to improper fractions. So let's do that. 1 times 10 is 10, plus 7 is 17. This is going to go to 17 over 10. We've got this one, so you've got 2 times 6 is 12, plus 5 gives us 17 over 6. Okay, now we need to carry out the addition. So we're going to look for our lowest common multiple of 6 and 10. Well, 6 times 5 gives us 30, and 10 times 3 gives us 30. That is going to be the lowest common multiple. Okay, so we're going to have to times, we're going to make this first denominator 30, and the second denominator 30 also. So we're going to times this first one by 3. Let me just scribble out some 17 times tables. So 1 times 17 is 17. 2 times 17 is going to be 34. 3 times 17 is going to be 51. So this is going to be a 51 over here. So that's our first fraction. These two fractions are the same. They're equivalent. This one is just top and bottom times by 3 for this one. Now I need to convert this to something over 30. So we did 6 times 5 to get 30. We're going to do 17 times 5 to get 30. 17 times 5. Well, 17 times 10 is 170. Half of that is going to be 85. So times 5 must be 85. Right then. So now we've got to carry out that addition. So we're going to add 51 and 85 to give us 136. The denominator stays the same. Right, we're going to split off into 2 directions here, just to show it can be done in 2 different ways. We're going to convert this into a mixed number and then simplify. And then in the other method, we're going to simplify and then convert it into a mixed number. Okay, so partly the reason I have split off into 2 directions is because it's not always intuitive. One may be quicker than the other, but if you can spot one, it'll save you a little bit of time, but it does not necessarily matter. Okay, so my brain here goes straight away, says these 2 are even, so we can simplify this. So let's divide both of them by 2. So 136 divided by 2 is going to be 68 over 15. Okay, do these share any more factors? Well, 3 and 5 are the only factors of that. 3 does not go into that, 5 does not go into that. So this cannot be simplified anymore. Okay, now we have to turn this into an improper fraction. Okay, we can do that. I just am more confident in my 30 times table because it's very similar to my 3 times table than I am in my 15 times table. We'll both get to the same correct answer, hopefully. Let's have a look. So let's convert this one into a mixed number. So my 30 times table, I know that 4 times 30 is 120, but 5 times 30 is 150. Okay, so it's going to be 4 would give us 120, and that is 16/30ths left over. Okay, so that's that converted into a mixed number. Now we can look at this second part, the fractional part of the mixed number, and simplify that. So I see both of these have a factor of 2, so I can half the top and bottom to get a final answer of that 4 is not being touched. 16 divided by 2 is 8. 30 divided by 2 is 15. That's your final answer. Okay, now let's have a look at this way. So We've simplified first. Now we're going to change it into a mixed number. So I'm going to quickly jot down my 15 times table. So that's 15, it's 15 times 1, 15 times 2, 15 times 3, 15 times 4, 15 times 5, and we've gone too far. Okay, so I can see that it's 4 lots of 15. So that means our first number is going to be a 4. What's the difference between 68 and 60? Well, that's 8 15ths left over. Okay, so we can get to the correct answer that way as well. As I said, so long as if you've got a flow and you're happy to go one way is not necessarily quicker. I just think working with my 30 times table is slightly easier than working with my 15 times table.